Hello everybody, welcome back. I just threw up a subnetting video and I'm in the process of uploading a remote management video which will pretty much walk you through how to connect to a device remotely once you've applied a IP address, subnet mask, and stuff like that. So there's going to be some well, there won't be really any questions to it. I mean, I think I was pretty straightforward. Um, every way that I've ever been shown how to remote into a device is there. So I hope that it's informative. So if anybody has any questions or anything like that, rriker82 at yahoo.com, rriker82 at yahoo.com. Shoot me an email. Leave a question there as a comment if you want. I appreciate feedback, negative or positive. If you don't like the video, you think it's crap, or whether you love it and maybe it helps, or different way of seeing something. I do. I like feedback. If you don't want to give feedback, that's fine too. But you can pretty much see right here at the bottom where I've pretty much laid out what I'm going to cover, how to connect to a switch. Well, I covered that already in remote management, so I might take just a couple of minutes and explain that. But there are different there's the ports on the switch are all going to be Ethernet, especially on this switch right here, which actually I will bring over the switch and I will zoom in so you guys can see what the switch looks like. This is a virtual switch, obviously, because it's on my computer and I can connect to it. Well, basically what... Can I zoom in any closer? No, that's it. Original size? No, I don't want to zoom in. The idea of a switch is for the end users, the servers, the printers, the wireless access points. I can't even think of anything else that would connect to it. I'm sure there are, but the idea of a switch is for the end user, the access layer. Well, more than just the access layer, but for the most of the time, it's going to be your access layer. The access layer in general is going to be what your end users, your servers, your printers, your access points, your WAPs, as they're commonly referred to, connect to. The nice thing about switches is they're pretty much plug and play. Unless you really want to get technical and finicky with it, a switch is pretty much you plug it into the switch port as long as it's powered on and has a connection to a router and has a default gateway. It pretty much does its job. I mean, there's really no config that you have to do to it other than, apply an IP address to it so you can remotely manage it. That's about it. If you don't want to do anything with your switch, you don't have to. All you have to do is turn it on, plug it in, or I should say plug it in, turn it on, connect it to a router if it's just strictly layer 2, apply an IP address to it if you want to be able to remotely manage it, and away it goes. If you don't want to do anything else with the switch, you don't have to. In effect, at that point, basically it becomes a hub. And everybody knows, well, actually, no, I won't go there because not everybody knows, but there's a switch that doesn't do anything other than move packets, or I should say frames, from one port or one PC to another PC, is a glorified hub, in my opinion. Now, that won't be necessarily true in all regards, but there are some things where that's exactly what it is. It's just a glorified hub, or a smart hub if you're, if that's your how you do things. Now, what makes a switch a switch? Well, a switch is different from a hub in a couple different ways. One, let me tell you what a hub does. A hub simply repeats information. Okay, what do I mean by that? Well, let's say for instance that a device plugged into this port right here, any incoming traffic going into this port right here from a device will simply get forwarded out to through port 24 all the time. All this thing does is it takes whatever data comes in here and just rebroadcasts it out all these ports right here. Okay, that's all a hub does. It's a repeater. It can be used as an intermediary device. Also, intermediary basically means it's in between the source and destination. That's basically all that means. So An intermediary device could be a switch, it could be a router, it could be a repeater, it could be a bridge. Now, I've mentioned a few different devices in that line, but the one that we're specifically focusing on right now is the switch. Now, a hub, like I said, brings in data on port 1 and forwards it out port 2 through port 24, because I'm not going to count 2, 3, 4, 5, 5, and so on. That's all a hub does. It doesn't do anything else. I mean, would you really want it to do anything more? Well, yeah, you might, but that's not what it's designed for. You can look at a hub as like a terminal, if you will. Okay, and I come from 10 years of warehousing, working on in shipping yards and shipping docks where you have tractor trailers backed in, and you pull the freight off of them. It gets dispersed to wherever it's got to go. That's kind of more like a switch in some regards, because product or freight coming off the truck doesn't necessarily always go out all the other doors. You follow what I'm saying? So I mean, unless there's like only 3 doors in your dock and you have 1 door for receiving and 2 doors for shipping, and then stuff is constantly going out the other 2 doors, then yes, it would work. But in the docks that I worked on were pretty big, 10, 20, 30, 40 doors. Now some people might go, well, that's not a big dock. Well, in a million square foot warehouse, having 50 doors, that wouldn't necessarily be a big warehouse or shipping dock, but when you're working on what they call cross dock, where all it is just a long garage with a bunch of garage doors on each side of it, and trucks back in and offload their freight. Well, that's what they call cross docking. Cross docking is exactly what a switch does. A switch brings in information on switch 1, or I'm sorry, port 1, and forwards it out at first out all ports. Well, that's what a hub does. So what's the difference? Well, it's a big difference. Okay, and well, actually, in that regard, it's the exact same thing. Before a switch learns the MAC address of the device plugged into this port. So, and let me be specific about this. The switch, the chassis of the switch has its own MAC address. Okay, then each port on the switch has its own MAC address as well, unique to each port. So it might be all zeros and then a 1 at the very end. Okay, and this might be all zeros and a 2, a 3, a 4, a 5, and so on, all the way to 24. That might be how the MAC address is laid out. MAC address being the physical address of this port. Okay, that's how the switch knows which port. Now, going one step farther, if you plug a computer, a laptop, a printer, a desktop PC, whatever the case may be, any device you plug into this port right here, once the switch learns the MAC address of the network card on the device that is connected to this, not this port right here, but the device that's plugged into it, the network card on the computer you're plugging into it. What it does is it learns the MAC address and saves it into the CAM table, the Content Accessible Memory. What that does is it's like a database. And what that database does is it says, okay, on port 1, I have MAC address ABC. So anytime that the computer plugged into port 1 sends information, sends frames in here, which is layer 2. Layer 2 is frames into port 1. Until there's other devices plugged in, it just sends it out all ports. Okay, it just broadcasts it. Now, if you have a computer plugged into, say, port 24, the same concept applies. It's going to ship it out all ports until it learns the MAC address of this one. So what ends up happening is, what it does is it receives something in on port 1, sends it across the line and throws it out port 24. Now, here's one thing I don't know for sure, that I've heard anyway, that when you have only devices plugged in, if this port has something plugged in and this one doesn't, that only this port will receive the frame. Okay, so theoretically, if you have information coming in port 1 and you've only got another computer or another device plugged into port 24, that this device will send to this device, and that's it. Now I don't know if that's true, because that would break down the actual architecture how a switch forwards frames. Now, if you're a exam candidate for the CCNA or the CCENT or whatever, your answer for your exam will be out all ports except for the one that it was received on. Well, why is that? Well, that's really simple. Because of the fact that when you receive something in, it won't forward it back out because that would create a loop. And you don't want frames looping in your network because that'll cause a lot of processor cycles on not only the switch but the computer, because the computer goes, well, hey, I just sent that, why are you sending it back? So what'll end up happening is there's this rule called split horizon, and what split horizon does is if it sees traffic coming inbound and doesn't know where to send it, it broadcasts it to all the other open ports. So now that might be the absolute answer, end all be all. So it might just be it sends it out all other 23 ports, and there isn't a technicality of it shipping out only the ports that have something plugged into it, which is what my theory would be. But if something comes in port 1, it gets forwarded out all other ports. So we're just going to go with that. So it comes in here, gets shipped out. So is that good? Well, yeah, it can be, because then you guarantee delivery. Okay. Now, what happens? So now I know you guys have the port for or frame forwarding concept down. So you know whatever comes in here gets forwarded out all ports unless there's a MAC address, unless the MAC address table is built and it knows where to send based on the source and destination frame header in the in the packet when it receives it. So comes in here, it knows that it's going out port 12 based on its MAC address statement, and then out the door it goes. Now, how does it know that? Well, there's a thing called ARP, Address Resolution Protocol, and as Jeremy Char from CBT Nuggets would say, ARP! ARP! Where are you? That's basically what ARPing does. It says, what is the MAC address of this IP address? So, if it knows the IP address on this guy here is 10.1, then, well, not 192.168.10.1. So if it knows the IP address, what it does is it does an ARP to find out the MAC. It's a layer 3 to layer 2 resolution, IP to MAC. Now there's also a thing called reverse ARP, which means where it knows the MAC but it doesn't know the IP. So it'll do a reverse ARP. It'll know the MAC, so it knows where to look, and it says, okay, what's the IP address, and it pulls the IP. So that's how ARP and reverse ARP work. So now that you understand the basic concepts to that, then it's easier to move on. Now, down here it says which ports do I use, or which ports do what. Well, there's actually only technically two different types of ports in switching. There are trunk ports and there are access ports. Trunk ports connect you from one switch to another through a crossover cable, and in some cases, excuse me, what they call a stack member. A stack member is just a fancy, it looks similar in some ways to an HDMI cable. So if you have HDMI at home and you like watching anything on 1080i or whatever the case may be, stack member is a 10 gigabit per second cable connection between two switches. Basically what that does is it allows you to take two switches, two 24-port switches, use a stack member between the two of them, and what it does is it basically makes the two switches appear like one in the operating system. So it's like taking, well, that's exactly what it does. It takes that stack member, like I said, it makes two switches appear like it's one. So when you go in and you log in, and instead of being 0/24 and 0/ having to go into two different switches, two different IP addresses, you can assign one IP address to, say, 3 switches or 4 switches, put a stack member between them. So one, it eliminates spanning tree out of the situation. So not only do you have a loop-free topology at layer 2, you also have increased speed between your switches. Now, if it's your backplane of your switch is always going to be significantly faster than any cable. Okay, so your cable might be gigabit capable, but your backplane of your switch is going to be 100 gigabit capable. Now, what does that mean? Well, that's how fast the transfer is going to be from port to port. So all these, the transfer on the switch itself. Now, you see right here it says 10, 100, 1000 base T. That means that it's going to be able to send at, can't speak sometimes, 100 meg or 1000 meg gigabit speeds. That's gigabit. Base T, which means it's base band, which means one signal at a time. Not single duplex, not half duplex, but it's not like broadband or broadband like your internet connection or your cable TV, to where you can have, say for instance on your cable TV you have 100 channels that you can switch between. Baseband means there's one channel, which means you're only sending and receiving Ethernet as your channel. Okay, so that's what that means. Now, like I was saying, there are only two ports. There's trunk and then there are access. Now, with the other part of trunking is if you have a crossover cable between two switches and it's 100 meg, so you plug it into this guy on switch 1, port 1, and you plug it into switch 2, port 1, then you have a trunk connection between the two. You configure it as a trunk connection in the iOS, and then the two switches are able to talk to each other. Now, you can double that up and have two connections, but based on normal spanning tree, which is what this guy right here is, normal spanning tree, the switch, one of the switch port, or one of the trunk connections will get blocked. Well, what does that mean? Well, what does that mean? It's actually really, let me give you not a router. I want to do a switch. So we're going to do this, and then we're going to bring it together with a crossover cable. So what is going on here? It's not responding. It's being funny. What? Don't tell me that. That didn't work. It's being funny right now. That didn't work either. So that's the drawback with software programs. Sometimes they act up on you. So there it goes. I didn't want to do that. I didn't want to do that. It's being funny, like I said. Now I'll explain why these are orange here in a second, but let me add just one more connection in. Okay, now this is what I was referring to having two trunk port between the two switches, and basically what that does, excuse me, is it allows you to send data from one switch to another. Well, as you can see, this port and this port are now green. So actually, let me do view, options, preferences. There we go. Now it's just showing you. Let me do that instead. So, anywho, now that you see, now this one switch right here, it's showing down fast Ethernet 0/2. Now, why is that doing that? Well, I'm not going to jump into spanning tree in depth because of the fact that it's actually it could easily take an entire half hour, 45 minutes to fully explain how spanning tree works, and right now this is not the point of this video. I will do another video on spanning tree and how spanning tree, rapid spanning tree, per VLAN spanning tree works. Somebody that's studying for the CCNA is going to have to know how that stuff works. So, well, I've been studying for the exam for a while now, and actually the CCIE written is what I'm after. So, but anyway, as I was saying, now you have connections between both switches, two connections apiece. There's a thing called ether channel. An ether channel allows you to take these two connections and basically make it look like it's one. It's a logical combining of both links to both switches. So what it does is you have, say, let's go gigabit, because they're capable of gig transfer speeds. You can actually go in on this switch right here. Let me bring up this switch too. So the identical switch. So you can actually go in on this guy, and I'll scroll this guy over, and this guy right here, zoom in and scroll over. Now you see how they're both 1000 base T? You could theoretically, on both switch ports, go in and configure them to gigabit speed. So you type in speed 1000 on your interface configuration mode, hit enter, and now it's gigabit speed. And what you would do on both sides of that is you would set it for gig speed. So both links, full duplex, meaning they're talking and receiving at the same time. Talking and sending and receiving at the same time, probably the better way to put it. Sending and receiving at the same time. So when they're sending and receiving, they're sending at gigabit speed, so 1000 megabits per second. That's pretty quick. So that actually can be combined to be 2 gigabits per second, which is pretty fast. So you could theoretically, well, not theoretically, the idea behind Ether channel is you to take the iOS to take that into what they call a port channel and configure it in such a way that it looks like to the switch that it's 2 gigabit connection. So what it does is it load balances per packet over the connection. So it makes you able to scale your speed of your network so that you can you more utilize your redundancy, because theoretically by default, like if I was to do this, no, I'm going to do this myself. So, notice how this guy's orange. Now what'll end up happening is if I cut the good one, that after so long this guy will turn on. Well, why is that? Well, there's this thing called failover. And what ends up happening, in a brief explanation of how spanning tree works, spanning tree, if you have redundant links, will block one of them. Then there's a specifics in how that works. And really it's not that difficult. But in order to fully understand the concepts, because there's a lot to it, and how understanding what different ports do and the directions they point, and how the switch determines which, see how that one turned green right there? Because the other one failed over. That one, it went from blocking to listening to learning to forwarding. That was blocking, listening, learning, forwarding. So now that these ports are up, you can send data across them, which makes your life that much simpler. Now, redundancy is just that. It is a backup. Now, redundant, if you were to look up the dictionary version of it, is to, it's a backup, it's a failover, it's an alternate. Redundant can also mean slow down, to prevent, but it's a prevention, in other words. So if there's we're proactive in the networking industry, so we're proactive and we have preventive measures, meaning we make sure we watch things that are going, and if we know something's going to go down, we make sure we have other setups in place, so if something goes wrong with A, that we have B as a backup. Well, that's the same concept with doing dual connections to switches. Now, you don't need to worry about spanning tree if you have two switches and one trunk port between the two of them. So if you have one individual line going from one to the other, spanning tree doesn't even come into play. Well, it still technically does, because the fact that it's got to choose who the root bridge is, and the root bridge is a whole other that's a whole other video in itself, because the root bridge election process and how VLAN trunking protocol comes into play, that's a whole other video. So I won't even go there. But now it says, what is a VLAN? Well, I'm going to bring up this guy right here, and I'm going to blow it up, and I'm going to zoom it in. So a VLAN is a virtual LAN, meaning what you could do when it comes to it is, a few years ago when I first got into networking, I didn't understand it. I had no idea what it meant, that type of stuff. So it took me a long time to get the VLAN concept. What is a VLAN? Why? I kept on hearing virtual. What does this virtual thing mean? I heard virtual machine VMware, where you could have a operating system loaded on top of another operating system, and then there was VLANs, and then there was all these type of virtualization. Hyper-V from Microsoft, and I was like, what is all this virtualization crap? Now I love it. I think VLANs are the greatest thing in the world, because it's so easy to scale a network nowadays that when you walk in, the first thing I ask is, what type of VLAN, what's your VLAN topology look like? you know, and we're not running VLANs. Well, why not? Well, because we don't know how. Okay, well, that's why I'm here. So, actually, this is actually beneficial for me because, and I've actually got the exact same switch you're looking at here in my house. I'm looking right at it. You can't see it, but I can look right at it, and I have 4 of them. Well, anyway, that's another story. I'll explain when I get to the routing. But a VLAN is a virtual LAN, meaning, and it's actually a really, really easy concept. So, you see this yellow mark right here, where my mouse is, and this one right here? Imagine if this switch was broken into 3 sections. Okay, so 1 through 8, 9 through 16, and 17 through 24. If that was the case, okay, if these guys right here were these 8 ports, these 8 ports, and these 8 ports, if these 8 ports were their own switch, these 8 ports were their own switch, and these 8 ports were their own switch, they would be considered in their own broadcast domain. Now, I don't have. Let me pause the video real quick and do something. Maybe I can make it easier for you to understand. Okay, so what I did is when I took a picture of the VLAN, or not the VLAN, but the switch, and I brought it into Paint because this is the only way that I can draw so you guys can, you know, see what I'm talking about. So, let me, where's the mouse? Alright, just in case I need to draw. Okay, beautiful. So, imagine, okay, so this guy right here is the break line. Imagine this switch was 3 switches. Okay, so actually let me do this real quick. The concept behind a VLAN is, and VLAN equals a subnet equals a broadcast domain. What does that mean? Well, in a nutshell, a lot actually. A VLAN equals a subnet equals a broadcast domain. In a modern environment, you're going to have a thing called a VLAN. And a VLAN, in its own sense, is a broadcast domain. So, remember how I mentioned when something comes in this port, it gets forwarded out all these other ports? So, it comes out all these ports right here. Right? So, it comes out all these ports. That is a broadcast domain. Okay? So, theoretically, VLAN 1 by default is VLAN 1. That's what you get when you first put a switch into production. It goes on VLAN 1. That is its own broadcast domain. Now, if you were to create VLAN 10, 20, 30, 40. Now, I'm writing with a mouse, so it's not going to be pretty. If you were to have these VLANs too, this would be its own broadcast domain. This would be a broadcast. This would be a broadcast. This would be a broadcast. And at the same time, you'd have VLAN 1's subnet, you'd have VLAN 10's subnet, VLAN 20's subnet, VLAN 30 subnet, VLAN 40 subnet. So you'd have the 1 dot, actually the 1.0, the 10.0, the 20.0, 30.0, the 40.0. So you'd have subnets for each one of these. Now what you could do with these subnets is you could, and this is the beauty of it, is you could have ports 1 through 8, this guy right here, in VLAN 1. And then you could have ports 9 through 11, or 9 and 10 in 10. You could have 11 through 12 in 20. You could have 13 through 16 in 30. And let's say 17 through 21 in 40. And 22 through 24 in VLAN 1. And what would end up happening is only traffic on VLAN 1, any traffic that was originated in VLAN 1 would come out ports in VLAN 1. So it would come out just these ports right here. And then these guys down here. That's it. Nothing, none of these other ones. And only traffic on VLAN 10 would come in and out of VLAN 10 ports. Same thing with VLAN 20 and 30 and 40. The concept applies no matter what VLANs you're working with. And that's the beauty of the VLAN concept, because then you can set it up to where you could have multiple switches. They're all trunked together. They're all one big happy family. And then you can have hundreds of VLANs if that's the way to do things. So what you could do, I run out of buffer. What you could do, really simply, I really wish I could do the erase thing. Hang on one second. Okay. Oop, missed it. There we go. You could have, where was I going with that? When you're dealing with VLAN 1, like I said, all this stuff comes out VLAN 1, VLAN 10, VLAN 20, VLAN 30, VLAN 40. Let's say, for instance, you have servers. Okay, well, your VLAN 10 will be servers. VLAN 20 will be your wireless. I'm hoping this is starting to make sense. VLAN 30 could be your LAN, which is your plugged-in devices, your computers, just your computers. VLAN 40 could be your printers. And then VLAN 50 could be, what else would you have on your VLAN? Servers, wireless, LAN, printers. You could have your management. There we go. There, you could have your management on VLAN 50. So what you would do is, on the switches, you would set it up to where you would have, you could set an entire switch to VLAN 10 so that it only does your servers. Now, theoretically, you wouldn't do that, but you could plug all these different devices into these different VLANs, and they're all on their own separate broadcast domains. So until you start routing them, Wi-Fi only sees Wi-Fi, LAN only sees LAN, printers only see printers, management only sees management, servers only see servers. That's the beautiful thing about it. Now, the thing about that some people don't like is what happens if something goes wrong. What happens if the router goes down? Well, let's say, for instance, you have a switch. Okay, you have a switch, and you have another switch down here. I'm going to draw these offset just so I can make my point. And you have a trunk port connecting to these two. Okay, and you have their switches. This guy's running 10 and 20. This guy's running 30 and 40. And then you have another switch. You have another switch down here. Made that a little boxier. And then this switch is running down to here. Well, this switch right here, this one is 50. Okay, this is going to be your root bridge. So it's going to be your fastest switch. It could be the exact same. It could be a 2950 like this one is. It really doesn't matter how fast the switch is. It could be just the switch you just chose to be the root bridge. This one right here is connected to a router of whatever size. So this is your router. I'm not the world's best drawer, but I'm making it work. And this guy is connected to a switch port here. Well, what ends up happening is, without you having any type of routing done on your VLANs, VLAN 10 is only going to talk to VLAN 10, 30 to 30, or 20 to 20, 30 to 30, 40 to 40. I mean, you get the drift. They're all on their own separate broadcast domains, which means they're not going to talk to each other. In order for any subnet, because they're all on their different subnets, right? This is a subnet, 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 subnet. In order for a subnet to talk to another set, there has to be a router involved. Okay, so VLAN 10 would send out traffic to this switch, so we're going to put 1, 2, and 3. So switch 1, VLAN 10, is going to send traffic to switch 2, then it goes to switch 3, then it goes up to the router, hits its default gateway, or hits this guy right here, which we'll say this is fast 01. So this guy's fast 1. That was actually a horrible drawing. 0/1. That's fast 0/1. So it comes in here. What happens? Well, what you have to do on the router is you have to set up a sub interface. So when you're under interface configuration mode, you type in interface fast 0/1 dot. Well, what happens when you type in the dot? Well, that's where your scalability comes into play. You type in the dot, then you type in, what I do is I type in the VLAN number. So if I'm going to do VLAN 10, it's going to be dot 10. And then, let's say for instance I'm using the 10 network, so it's going to be 10 dot whatever, so 10.1. I don't like using zeros because it throws me off. 10.1 dot 10 Anywho, sorry, I had to pause the video for a second and look at something. But like I was saying, in order for you to get your VLANs to talk to each other, you're going to have to route them. So what'll end up happening is like I said, under the interface, 10.1 dot 10.0 dot 0. So slash whatever, slash 24, whatever the case may be. So what you'll end up doing is you'll do that for everything. So fast 0.1 dot 20 dot 30 and so on. What that'll allow you to do is it allows you to scale and use the router to route your VLANs. So at that point, you'll be able to go under like whatever routing protocol you want to use. So like let's say for instance you're going to use OSPF. So you'll go under OSPF and then you'll say network, and then you'll type in the statement, 10 dot whatever, and then what 0.0.0.255, and then it'll route your VLANs for you. Now there is another version of switch routing besides that. Let's see how far this is going to take me back. That's what I thought. So hold on one second. There is one more way of routing your VLANs, and I will show you that right now. I erased what I had there, and I'm redrawing this. Yeah, it took a bite out of crime. Well, this is still switch 3. Okay, switch 2. So what ends up happening is this guy right here is going to be, say, VLAN 50 right here. Okay, we're going to have VLAN 50. And this guy will be VLAN 1. Let's just for instance. Now, this is what they call layer 3 switching. What is a layer 3 switch? Well, if a normal layer 2 switch is this big, this is from the top down, so this is top. A layer 3 switch is significantly bigger. Okay. Actually, they're exact same width, but they're like twice as deep, so this is top. What a layer 3 switch does is it allows you to put a router inside of a switch. Wow, that's a concept. Well, no, they didn't actually take the round, or the big round-looking thing and stick it inside of a box and call it a router, a layer 3 switch. What a layer 3 switch is, it's a software feature upgrade to the normal iOS of the layer 2 switch. Significant layer 2 upgrade, or software upgrade. What it does is it gives you the ability to IP route. So, in order to do this, you have to turn IP routing on. So on this guy you type in IP routing. So once you get IP routing turned on and get that situated, then it's a matter of going in and doing the same thing you did before, except for this time you're not going to do the sub interfaces. Okay, you're going to turn on what they call an SVI, or a switched virtual interface. That's the same thing as the FAS 0/1 dot 10.10 dot 20.30.40 till your heart is content. What this does is you go into global config and you type in interface VLAN and then the number. So we're going to go VLAN, let's say VLAN 10. What that does is it brings you into interface configuration mode. The same thing you would do if you were configuring, switch port 7 right here. Okay, same concept, except for this is a logical, or it's not real. It's not physical. You can't plug anything into it, but it's there. So what you would do at this point is you would tell it that you give it an IP address. You say IP address, and then you would give it the IP and the subnet mask. And then what you would do is you would plug um, your connections into this guy. And so what you would do is your layer 3 switch would be connected to both layer 2 or both the switch 1 and switch 2. So you would connect this guy to this guy, and then you could theoretically plug this guy into here. That's what I would do. Or you can have this guy plugged into here. But it's always easier if you have directly connected devices together, as much as you can. So what you'll end up doing is you'll end up using, say, 8 ports. If you say you have 4 other switches, and you've got these, let's say these 2 right here are going to switch 2, and these 2 are going to switch 3, these 2 are going to switch 4, and these guys are going to switch 5. So this guy will be connected to this guy, or I'm sorry, this will connect to switch 2, these guys will connect to switch 3, 4, and 5, like appropriately. And then you can have on these switches, so switch 2 would connect to switch 3, switch 3 would connect to switch 4, switch 4 would connect to switch 5. Now, if you wanted to be really redundant, you could go 5 to 3, 2 to 4, and then it would be done. That would get you complete redundancy. You can do that. It's not unheard of, but it's not a necessity, because theoretically your traffic will never be that bad. But you could do that. Okay, so let me go over that one more time. You could set it up to where these 2 ports. Let's say this is your layer 3 switch. Okay, so layer 3 switch. This is your layer 3 switch. Okay, even though it's not a layer 3 switch, we're just going to pretend it is. This is your layer 3 switch, and you've got the first 8 ports as trunk ports going to your other switches. So this switch is going to these 2 are switch 2, these 2 are switch 3, these 2 are switch 4, these 2 are switch 5, and then they have dual connections, and you get them ether channeled to the other 2 switches, or the other 4 switches. So what you could do is, and then at that point you would take either a single or double connection to switch 2 and 3, and then you would connect 3 to 4, and then 4 to 5. Now you could, theoretically, if you wanted fully redundant, like I said, connect this guy to 3, 5 to 3, and then 2 to 4. You could do that so it's completely interconnected. You wouldn't have to worry, and then you could theoretically do 2 to 5, and you could technically do, well, I don't see why you would want to do that, because that's just overkill. But you could do 2 to 5, because then the 5 would have connections to all 3. So what that would look like is this. Or actually, I should say, it'd be switch, 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 switch. So this would be 2, 3, make that 5, 4, and 3. So what you would do is you'd have a connection here, a connection here, a connection here, and a connection here. And then you would just cross them over. That's what it would look like if you were to draw them out. But it would normally look like you'd have switch, 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 and then this would be your layer 3 switch right here. And then this guy would connect to this guy, then this guy to this guy, then this guy to this guy, then here to here. Then this guy would connect to this guy, this guy would connect to this guy, this guy would connect to this guy, and then everything in between. So this guy would connect to this guy would connect to this guy would connect to this guy. So no matter which way you would cut it, slice it, or chop it up and throw it into a blender, they would all have connections to each other. That's what they call a fully redundant network. So, okay, why did you ramble on about all that redundancy? Well, in modern networks, if you have the money and the time and your network is dependent on being able to stay up, if one of these switches fail, it's going to have a connection to somebody else. That's the idea. Now, do you need to have it fully redundant like that? No. But is it nice? Well, absolutely. So what you would do at that point is you would have your layer 3 switch would have connections to all the other switches, and you would have switch virtual interfaces configured on your layer 3 switch using OSPF, and it would route your VLANs. Now, if 8 switch ports are route or your trunk connections, what do you do with these guys? Well, you can do whatever you want, really. You can make these access ports, and access ports connect to an end device, meaning a server, a printer, a PC, a laptop. No other switches. You could do a router, it could be a trunk port, but we're gonna go on the assumption that these are all access ports. So under these guys, right here, under the switch ports, the access ports, you would put port fast. F-A-S-T. What is port fast? Port fast is a spanning tree feature which allows you to plug in a device into a switch port and it automatically goes into forwarding mode. It doesn't look for the bridge or the switch, the process of going through blocking, listening, learning, forwarding. It doesn't do any of that. So what you would do is you plug it in to this port right here. It's connected. This light turns green, and up it comes. Now, one thing I want to cover really quick. You have, I don't know if I can zoom this in anymore. Resize. Can I go 125? I can. Awesome. Now, these are status lights right here, okay? Now, you've got system, RPS stands for redundant power supply. Utility, duplex speed mode. I'm thinking that says start, but I can't tell for sure. Or status, I'm sorry, status, that's status. I had to look at my switch right here, and so I know what all these do. Now this guy right here is an actual push button, so this guy you would actually push in. So if you push this button right here, it would toggle through all of these. System, if this light is on and green, this guy right here, if this guy's on and green, actually let me switch my color around. If this guy is green, and solid green, that's a good thing. It means it's booting, or it's booted. If this guy is on and green, that means you have 2 power supplies connected. Some offer that, some don't. Actually, all of my switches have the capability of redundant power supplies, and I'm actually looking at the back of mine. You'll have a connection, like a regular connection to the back of a computer plug, and then you'll have a 12 volt, 4.5 amp. What is that? 2, 4, 6, 8, 10, 12, 14 pin connector. It's about what would I say? Probably it's about yay big, and there's a line drawn in the middle of it, and then it's got something similar to that. That's basically what it looks like. And what it does is that's redundant power supply, so you're able to plug that into like a UPS or something like that. Now, if RPS is lit up, it's a redundant power supply. Now, if status is lit up, that means it's running. Okay. Duplex, if it's on, means it's 100 meg. If it's flashing, 10 meg. If it's flashing. Speed, if this is lit up, when these all won't be lit up at the same time. You'll only see system and status will be flickering. If speed is, if you press the mode button right here, and this guy, if this guy lights up solid, I'm sorry, duplex, boy am I dumb. This is speed, obviously. This guy is speed. Duplex, if it's on, it's full. on, flashing, it's half. Okay, so if it's on, it's full. If it's flashing, it's um, you. Oh, and then this is utility. If you press the button on this one, it'll show you which switch ports are actually being utilized. And what I mean by that is which ones are actually sending traffic. So you could have something plugged into this guy, and this light could be actually lit up green, showing that it's something connected into it. And it might be flashing, but if you press this button right here, and it gets to this guy right here, and this guy just doesn't do anything, then it's not being utilized. There's no traffic going in or out, okay? So that's basically how that works. Now, the beautiful thing about that is it gives you at least something to work with. Now, there are some switches that have the PoE. PoE is power over Ethernet, which means if you have a layer 1 device, like a wireless access point, that you want to be able to deliver wireless to somewhere, and you can't run power to it because, well, there's no power in the area, or it's just going to cost too much to have an electrician come in and run power, it's easier just to have a access point put in that can receive power over Ethernet. So what happens is the switch, see if I can, oop, don't want to do that. The switch, can we zoom in just a bit? Oh, I guess it's only one. It's all or nothing. The switch will have a power supply built into it that is getting fed from its actual power supply. So what will end up happening is it'll send power out the switch port. So now if you stick your finger in there, no, you won't get zapped. At least I don't think so. So it sends power over the Ethernet cable that you have plugged in here that goes to the access point. So let's say this is an access point. Now this guy's powered on, so if you were to press the power, this guy right here, it would power, it would receive PoE through the Ethernet to the access point. This is also very usable with voice over IP. So let's say you have an IP phone. So you have an IP phone, and then you want to run PoE to it, so that it's running PoE. So then, now the only thing with that is you have to be running CDP, Cisco Discovery Protocol. It allows you, it's a layer 2 keep alive, and it's used every 60 seconds, so CDP. CDP, it allows you to see what other devices that are Cisco or that are on are in your network. So switches, routers, things like that. Access points, IP phones, call manager, express, servers, that type of stuff. So it allows you to see all this stuff. So you'll be able to run PoE and CDP. Now CDP will point it to where it's got to go, like call manager, server, and tell you what type of IP address it is. There's different levels to this. It'll tell you like the IP address, the switch port that it's connected to, and all that stuff. When I get into the iOS, I'll show you how this all works. But that's how that works. Now the nice thing about that is this allows you to, let me switch my color back to red. Red seems to be the best right now. If you're running PoE, the switch is going to be significantly more. Now there are layer 3 switches that run PoE. 3560s are capable of doing that. I don't have any PoE switches here at home because I'm not running voice in the house, nor do I plan on doing it. But I've spent enough time in the industry to know that voice is kind of the next thing. I'm a security guy myself, so I'm more interested in the VPNs and the IP security and ACS servers and TACACs and stuff like that, and how knowing how I can use AAA on the router to allow you to only be able to use certain commands at a certain place at a certain time and stuff like that. So I'm a security guy by trade. I'm going to school for it. I'm working on Security Plus through CompTIA. Eventually, my ultimate goal is to get the CISSP, which is the CISSP, CISSP. This is the big dog of all security certifications. It's like the CCIE security, so the CCIE, and then you have all your little tracks that go along with it and so forth. CCIE security focuses on Cisco security itself, VPNs, that type of stuff, access lists and things of that nature, ASAs, firewalls, that type of stuff. CISSP, if you go to the iscsquared.org website, the International Security Consortium, whatever it all equals out to. The CISSP is the Computer or Certified Information Systems Security Professional, and it is like if you have a CISSP, there's something to the effect that you've got to be sponsored by somebody. You have to have a certain amount of experience. It's some like ungodly tough test. It's like supposed to be worse than CCIE security, but this isn't vendor specific, from what I understand. This is more along the lines of security as a whole, if you will. So if you're a security professional, like you have a CCIE security, and you have a security plus, or forget this, CISA, I think it is put out by the same company. CISA, Certified Information Systems Auditor, or some, I'm not sure. It's like the CISP. It's a step down from this guy. That's all I know. If you go after that, that's like another really difficult exam to pass. So if you're a CISSP, which actually I work with a guy who's a CISSP, super nice guy. He can tell you anything you want to know about security, intrusion prevention, IDS, IPS, firewalls, ASAs, you name it. The guy's like a security expert. Well, he is a security expert. So if I was to have my own security, this is what I want my resume to look like. Okay, let me just zoom this down real quick. I would like to have, let me type this, this would be easier to type. My resume would look like this. It would be CCIE, I'm actually looking to get 4 of them. Okay, CCIE times 4, whatever my number would be. So, colon and then XXXXX. It would be the XXXXX, and then because it'd be a 5-digit number at this point, and it would be route and switch, service provider, security, and then I want data center. That's what my CCIEs would be. That's what I would like to have. I would also like to have the CISSP, and then the number that goes along with that. So XXXXX, and then security plus. Actually, we'll go net plus. I like that, the net plus. Now I've already got the A plus, and then I'm trying to think if there's anything else that I would like to have. Nothing's coming to my mind at the moment, but those are the maybe a Microsoft certification or 2 in there, or maybe a Linux, but that's what I want my resume to look like. CCIE. I think there's some vendor neutral stuff in there besides the CISSP and CompTIA, but that's what I would like to have my resume look like. Now, is that overkill? No, I don't think so. I think it encompasses everything that I'm going for. It's definitely it entails a lot of stuff. I mean, there's going to be a lot of training involved to get to that level. Now, I'm 30 years old right now, and it's 2013. So you figure I'll be 31 in this August coming up, so in 9 months or whatever, 8 months. I'll be 31, and uh, could I push harder to get the CCIE? Yeah, of course, everybody else could. But right now, my main goal is to learn the technology. Like right now, I didn't have to look any of this information up over on this guy. So coming back to um, coming back here, I didn't have to go on Google or Google any of this stuff. This is off the top of my head. Now, is it difficult information to know? No, not at all. This is all CCNA level stuff because this is what I'm trying to teach is CCNA level stuff. I haven't gotten into frame relay. I haven't gotten into accessless or NAT or anything like that. But what I'm trying to do is I'm trying to explain what I know how to do, and I struggle with something still at the CCNA level because of the fact that I've dove into other things, and I'll eventually come back to them. So ACLs, I mean, I know what an ACL is, and I know exactly how to read them and how to implement them. But um, can I teach it? That's the question. So what I'm actually going to do is before I teach NAT, I'm going to make sure I understand NAT, and then I'm going to try to apply it. Now, the hard part in the lab environment to apply NAT is very difficult because of the fact that you're dealing with um, typically a simulator, and well, NAT you're going from public to private. So when public addresses to private addresses. So anything that's not private addressing scheme, so all your public IP addresses, like your 12.1.1.0 slash whatever. So that's what that's one thing I got to cover yet. But beyond that, I'm pretty comfortable with everything else. So, will I eventually come back to it? Oh, absolutely. I definitely will cover it. And actually, I needed a. I was supposed to come downstairs, but this is where I'm at, my downstairs in the bottom floor of my house. I was gonna come down here and go through a couple of Cisco videos, but I checked YouTube and I was like, I'd rather just teach. You know what I mean? Sometimes you get tired of listening to somebody talk. I just, I crack myself up sometimes. You guys are probably tired of listening to me, but um, that's basically where it sits. I'd rather pay it forward when I can if I need to break from studying. Because that's what I'm all about. I'm all about trying to help the next guy out because somebody took the time to record video and explain Cisco. So I think I know it fairly well, and um, people that I go to school with, they're like, "Dude, can you show me how to do this?" Not a problem. What do you want to know? What are you trying to figure out? I'm always willing to take a few minutes to show somebody how to do something. I used to get caught up because my classes run from 5:50 to 9:50. Well, they were because I'm all online this semester, but last semester they were all 6 to 10 roughly. So I get to class at 6 ish, maybe a little early, and then you listen to the lecture, then you do your lab work, whether it was server, Cisco, Microsoft, whatever. You go through the excuse me, it's getting late. It's almost 11 o'clock. You go through your lab, and I'd be done with my lab pretty quick because I'm very familiar with Cisco and how things are implemented at the CCNA level. Actually, I work at this more at the CCNP level at work because of what we deal with, and I touch CCIE material throughout the day based on some MPLS and frame relay advanced stuff like arguing, bursting, and stuff like that with ISPs for customers and stuff like that. But I won't get into any of that type of stuff because that's way beyond the scope of the CCNA frame relay. But a lot of what I do day to day is stuff that I can easily teach you guys because, well, it's something I know how to do. If I can get on the running look to do a show run on a router and be able to thin through it, there might be some voice things that I'm not 100% on, and ISP stuff like T1, T3, DS0, DS3, Metro E, stuff like that I'm still not 100% on. Then I'll ask a question. My boss at work, he's like a 30-year veteran of AT&T. So if we have a question ISP wise, we ask him, he's able to answer it. So we never have a problem when it comes to getting questions answered and stuff like that. So, do I enjoy my job? Absolutely. It's one of the best things I ever could have done was to get a job where I work in such a large environment and I have people that I can rely on. I've only been there a month, but people are able to, ask me questions about things. Have you seen this? Or I'm willing to forward my 2 cents in. If it applies, they use it. If they don't, then it'll get discarded. But there's been a few times where it's usually been minor things like for instance, there's a thing called DHCP relay, and basically the way that works is let's say you've got um, what do you call it? You have a network and you have a switch. Okay, you have this switch right here. The switch is connected to a router, and then this router is connected to another, let's say the WAN connection. So what ends up happening is this guy's connected to another router over here, and this guy's got a DHCP server. Okay, so what ends up happening is this guy is a computer somewhere on a network. All right, so this is the computer. I know it's a horrible drawing. This guy boots up and it requests a DHCP, does the DORA. Okay, discover, offer, request, acknowledgement. So it does a DORA, does a discover, hits the router's interface and says, hey, I need an IP address. Now this is an all 255's broadcast. It hits the router goes, well, I don't have DHCP running, so they put the IP helper address. I'm going to just HLPR address. And then he points that like a static route pointing towards this guy. And then this guy receives that and says, oh, so you're looking for this guy right here. DHCP goes, okay, here's his IP, blah. Ships it back out this way. Now from here it's all broadcast. Okay, it's Bcast, and then from here and then back it's unicast. Okay, so this way it's unicast, and this way it's unicast. So it goes this way, hits this router talks to this switch server, and this guy sends it right back out. This guy gets a broadcast address, comes back down here and says, okay, here's your IP. This is the offer. The offer comes in, and then this guy goes, okay, that's what I want. Then this guy, it's sent back as a request. It says, okay, I want to request that. It goes back across to the server. The server says, okay, I'm taking this IP address out of the pool and putting it into the binding that you have it. And then it switches it back. This is unicast in, and then it says acknowledgement. So now you have this IP address for whatever the lease time is, 12 hours, 1 week, whatever the case may be. So that's how that works. So you'll run into situations like that where bandwidth is increased in the morning, and then it might be say a 2-hour lease. You might only have an IP address for 2 hours. Now a lot of the times what we deal with in our environment at work is you'll have like the WAN cloud, and then all these branch offices connected to the WAN cloud, whether it's MPLS or Frame Relay or what have you. And all these guys, you got these routers here, and I'm being sloppy in my drawing because I want to finish this video up. But all these routers, and let's say branch 1 is the main guy, and then he has connections to all these guys. Okay, so this is all the backbone to this guy. DHCP sits right here. Okay, so what ends up happening is anybody on this guy's LAN, okay, he comes in, I need DHCP. Then it's got to come all the way up here, come across, go up. And as soon as it leaves this subnet as a broadcast right here, it's unicast all the way up here. So it's unicast until it gets to here. Then the DHCP process comes in. So the DORA happens here. Discover happens here. Then he sends it back, gets the offer, And then he goes, okay, I want that one. The request is sent back. He goes, okay, I'll take that one out of the pool. The acknowledgement comes back and it says, okay, you have it. And then, now if the lease is hourly, and then typically it's always half that time, so you can keep it. So you're always sending it back and forth. I usually do 7 days. Okay, 7 days as a lease, so that cuts way down on your broadcast time. Now, assuming everybody shuts their computer off at the end of the day, and then comes back in, the process happens all over again. The discover, offer, request, acknowledgement, that stuff comes and goes every day. As often as that person either reboots their computer, restarts it, shuts it off, whatever. This stuff happens every day. So that's how this stuff works. So now you know how VLANs work. Now you know how routing VLANs work. Now you know the logical separation in a VLAN. You can do router. You understand the concept of router on the stick. You understand the concept of layer 3 switching. You understand the concept of redundancy in a switch network, a stack member, how it makes two switches look like one, how to, you know how to do DHCP relay, you know what the CISSP is. What else did I cover? Oh, you also know the different status lights on the switch, what each one means, and how to hitting the mode button will flip through them and tell you what they are, and the light up, you know, what lights up and what, you know, each one equals, how PoE works. So I've covered a lot in this last hour, which what I should do is I should start breaking them up in smaller, you know, 15, 20-minute videos, so you guys aren't going, oh my god, I'm gonna listen to this guy for an hour. Oh no, you don't have to listen to me for more than 2 seconds if you don't want to, but it is what it is. So I'm gonna quit rambling because it's 11 o'clock and I want to go to bed. So I hope this has been informative for you, and I'd like to thank you for viewing.